Now, stretching, it's not quite as straightforward. It's not terribly difficult, but it's not as straightforward. So we have a vertical stretch here. Y equals a times f of x, right? If it's on the outside, everything proceeds as normal. We're just stretching out. So in this example right here, right, we've got when x is 1, y is 1. When x is 2, y is 0. Oh, sorry, I should have put that right there. All right, when x is 2, y is 0. When x is 3, y is 2. And then we go back down to that point there. And so here we've got our graph. Of our function, y equals f of x. Now let's look at 2 times f of x. When x is 1, y is 2. And I'm just multiplying this number here. That would be 0 again. And then this becomes 4. And then we're back down to 0. All right, so that is the stretched function. Right, x is 1, y is 2, down to 0. And then this guy would go up to 4. And then back down to 0. So you can see everything's being stretched away from the x-axis by a factor of 2. Right, being stretched away. So this one that's only 1 unit away from the x-axis, that's at 2. This guy that's 2 units away from the x-axis is 4 away. And note, if you touch the axis, it stays put because the further away you are, the more you get stretched. All right, so a couple examples here. So here, a equals 2. So again, when we go through, we stay put. Here we just go through. Right, since it's 2, we're just doubling the distance. And I'm just kind of eyeballing this, just what's about double the distance. So it's 1.5. That goes all the way down to 3. That stays there, and that's about up to there. Then we connect the dots. And again, note that where it touches the axis, the point is the same. Okay. Now we come over here. Note that a is a third. So that means we're shrinking it in, towards the x-axis. So here we're at -3, so it goes up to -1, right? Stays put there. And then right here, it goes put it about right there. And there's our graph right there. Right. And note that I'm only changing the y values. The x values stay the same. Okay, last page. Horizontal stretch. Now, horizontal stretch is a little different because it's inside the function. And the horizontal stretch is not b, the number in front of x. You take the number that's in front of x and put it underneath 1. That's how it works. So let's see this in action. First, I'm going to graph this guy here. When x is 3, we're undefined, 4 undefined, 5 undefined. When x is 6, y is 0. When x is 8, y is 3. And then when x is 10, y is 1. Okay, there's our graph. Now let's work this one. So this would be f of 2 times 3. In other words, f of 6, which is 0. And here f of 4, two times 4 is 8, and f of 8 is 3. And here at f of 2 times 5, which is f of 10, and f of 10 is 1. All right, so x is 3, our new y value is 0. So that goes there. X is 4, y is 3. And here, x is 5, then y is 1. So you can see the graph is being stretched in by a factor of 1/2. This point that's at 8 is now, or at x equals 8 and y is 2. Now it's x equals 4, half of 8, but we're still at the same height of 3. Right? And that is how that works. All right. Let's go ahead and put this into action now that we understand it a little bit better. So here, we're graphing y equals f of 3 times x. So that means our stretch is not 3, but it is 1 over 3. So this point out here comes into here. And same here, out by 3 comes into 1. Again, note that the y value is not changing. There you are, just like that. Same general shape, just a little squished. Now over here, 1 over b is really 1 over a half, which becomes 2. So that is our horizontal stretch factor. And so this point, where it comes out to 1, now it comes out to 2. Right here, this is going to, we'll go ahead and connect these right now. Goes out a little bit further before going up. There we go. And then this one that came to -1 now goes to -2. And there it is, just like that. Again, the y values stay the same. It is the x values that change.